can discuss a little bit, and then in a minute they can, so you at least have an extra, person to talk to. Oh, I'm blabbering on the internet right now. Okay, hold on. Okay, we'll start with chapter 1. This is going to start with a lot of geometry review. You take what you feel you need to take. I just figured I'd cut the opening cover. Remember the book's online? And the homework calendar's online. So you get all that stuff from there. Okay, so we're going to start off with this real Mickey Mouse first thing. Again, you write what you want to write. Do you feel like you have to write what a line is? I hope not. And I just realized I got to do something here real quick, but I'll try to do it while I'm talking. All right, so we're fine. We see what we need to see up there. Say no. Then go back to this. Okay, line, segment, and ray. So line, obviously, is denoted with a line symbol above it with arrows. Sorry for my sloppy writing as I have to reapply this. There we go. I just had to get rid of that. And then a ray. I wrote this with the other hour. Is this ray BA here? Well, no, because it says ray AB. But what's the other reason why this is wrong? What does this imply? Go ahead.
Usually when you read a line or a ray or a segment, it goes from left to right.
Well, it's not necessarily that. What's the starting point of this ray? A. It's not B. Okay, so this implies that I'm starting at B and going through A. So rays, you can't really switch the letters. Could I call this line BA, though? Is that legal, as a lot of people like to say? The answer to that is yes, because it goes through in infinite directions through both points. Whatever. Basic geometry review. I bet you this is new for 3/4 of you if I take the percentages from last hour. You better mark this down, man, or woman, whatever you are, and make sure that you understand maybe a new difference. And I can't tell you how important it is this first chapter is to solidify these concepts and not make mistakes on this. So, back in the day, there used to be clocks where the second hand would go this way, not these digital things. You ever see one of those before? All right, they're ancient. When I was in school, that's all they had. Hour hand and a minute hand, holy cow. So that's clockwise. So what's counterclockwise? The opposite direction. What's weird about math is counterclockwise seems to be the norm. I always say that because normal usually means positive to me, and abnormal means negative, or different means negative. Good, positive, bad, negative, normal, positive. So the normal direction in math is counterclockwise for an angle measure. So this is the new thing for the day, bet you, for most of you. When we do angle measures clockwise, that will actually have a negative angle measure. Weird. Now, those that know, there's like 4 or 5 people that would raise their hand. What do you think would be a reasonable angle measure for this angle measure? From here all the way to here. Anything would work. Go ahead. You said like 300. I would agree with that. Maybe 315, 310. Anything that is above, though, what number? 270. And what's 270? 90 plus 90. What else? Plus 90. You can see that this is 90 here. This would be 180 here. Another 90 would be 270, this vertical line down here. So 300 is a good guess. Now we're stuck. This is the same opening as this. So now what's this angle measure? And it has to be based off of this first answer. It's not 60. Kapow. It's negative 60. I got you. The wrath of the red pen will come out so quick your head will be spinning. If you put 60 for that, because why? What's the direction? Negative. You'll understand that point later when we go over that stuff. All right. I hope to goodness gracious we don't have to write this stuff down. Oh, look at that acute angle. What does that mean that is? It's very what? Small, or it's less than 90. Right angle, obtuse. What does obtuse mean? Large in the geometry sense, all the way up to 180, between 90 and 180. Of course, you should know what a straight angle is. And then actually, if you were not in honors last year, which I've got a feel now, honors, you did this negative positive angle measure stuff. Some of you may have never seen an angle more than 180. All right, and then you're going to have to actually get used to that. Obviously, a full circle is what? 360. Hey, okay, so let's go. I went to Walmart's parking lot last hour when it was snowing. So here I am. Here's my car facing Walmart's sign right there. What am I going to do in that parking lot if I'm illegal? What am I going to do? And it's snowing outside. I'm going to do a donut. I'm going to do a woo. But what do you do that? Hey, I just did a what? Don't say a donut again. I do it math. I just did a 360. Where are you facing? Where are you facing when you're done with that 360? The Walmart sign. The W in the Walmart sign. Hey, what if I do this? Hey, I'm facing the same direction, and I'm going to do this. Oh, woo! What did you just do? You just did a 720. Now let's pretend there's an observer off to the side. I can't look at this. This is, oh. And I hear the car, and then I turn. The one car is facing the Walmart sign, and then the other car, and it goes, and it's facing the Walmart sign. Will you know the difference of what those two cars did, yes or no? Well, maybe by the engine sound it went longer, but you didn't see them spin, so will you know the difference otherwise? No. Who will know the difference? The people in the car. So is there a difference between 360 and 720? One has more what? Well, I was going to say fun. Okay, but that's all right. And then what about this person? What if they do this? Then you could be like a mathematical. Well, you know what? I'm going to be different. I'm going to do this. Woo! And then they go, hey, you just did a 360. And you're going to say, no, I didn't. I did a negative 360. And they're like, what a nerd. No, I'm just kidding. All right, but you got to know the difference, okay? Got to know the difference in this class. All right, Mickey Mouse stuff. Complementary means two angles add up to what? 90. Supplementary means two angles add up to what? So far not bad. This is what I always tell my students. Who comes first, C or S in the alphabet? C comes first. Who comes first, 90 or 180? 90 is smaller than 180. C comes first in the alphabet. Complementary means 90. Supplementary means they add up to 180. So never flip-flop those terms. Got it? Okay, did I take attendance? Let me check. All right, this next part's going to be weird, but you know what? Let me just ask you this. How many, and it just went off, our time little thing, how many minutes are in an hour? How many seconds are in a minute? How many seconds are in an hour? 3,600. Now, believe it or not, degrees are cut the same way. Now, I can't even give 1 degree justice on this thing. I can't do it. So let's pretend we zoomed in with a microscope and this was 1 degree. By the way, 1 degree in this is like this. I could barely lift it off of that, right here. That's 1 degree from there to there, and I think I'm still not doing it justice. I think that's still bigger than 1 degree. That's 1 degree. How many minutes are in that degree? Take a guess after what I just asked you. 60. So I could cut this 1 minuscule degree into 60 equal parts. You think I could do that with my pen on here and make it look good? No. And guess what? Of those 60 minutes in here, I can take 1 of those minutes and cut it into what? 60 seconds. And you would really have to zoom in on that to see that one. So, just like in time, degrees are cut into 60 minutes, and minutes are cut into 60 seconds. So how many seconds are in a degree? 3,600, because there's 3,600 seconds in an hour, so there's 3,600 seconds in a degree. Now, as you're writing this down and trying to make sense out of this before I do examples, what's latitude and longitude do? They carve up what? What does latitude and longitude carve up? The Earth. Okay, so do you know like 1 degree? Oh man, I don't want to put this on the internet and be a buffoon. but I thought I remember 1 degree might be, I don't know if it's quite a nautical mile. I may be completely wrong. I did this once. We did this in math. I think it's going to come up later. We'll solve this later. I think I'm wrong. But it's at least a big amount of, it's not nautical, it's much more than that. So a degree on Earth, when you cut it latitude and longitude, is a huge amount of area. So what do we have to do with that degree? We have to cut it into what? What's the first cut? Minutes. And then we can take those minutes and cut them into what? Seconds. And then what we really could do is pinpoint a specific location on Earth by cutting those degrees into minutes and seconds. So there are uses for this. All right? And that's why they do what they do. You just have to be aware of it. And all I'm going to do for this set of notes, well, of course, all right, 1 minute equals 1/60th of a degree. Not yet. That said when convenient. It's not convenient right now. Thank you. All right. And then, of course, 60 minutes equals 1 degree. And then here's the real breakdown. 1 second is 1/60th of a minute, which is 1/3600th of a degree, if I could speak better. It's just like saying 1 second is 1/3600th of an hour, because there's 3,600 seconds in an hour. Don't overblow yourself on this as far as your mind getting exploded. But I am going to teach this just by shoving the work in your face here, and then we're going to do some other examples of this later. They do have some silly examples of converting degrees, minutes, and seconds to a decimal, and vice versa. The first one should make complete sense. Because let me ask you this, 30 minutes, what would you describe that as an hour? 30 minutes is blank hour. Half. 30 divided by 60. That's why. So what's 8 minutes? 8/60th of an hour, or 8/60th of a degree, because degrees are cut just like hours. And then 14 seconds, well, to figure out what that is as an hour, I have to divide it by 3,600, because there's 3,600 seconds in an hour. So there's 3,600 seconds in a degree. 14 seconds is 14/3600ths of a degree. And basically what you can do in even the simplest of scientific calculators, which I told you to buy, is type this as a string on your calculator and just press enter. That's all you have to do. I told you get a scientific calculator that you see as you type, so you don't have to worry about order of operations. I got my daughter one for 8 something at Walmart. I think that was a major sale, because usually we're on 12, which is not a big deal either. I'm not saying you can't use a graphing calculator throughout the year. We will, but you just can't on the final. So that's why we want to get used to that. Then the reverse. Let's reverse it. 0.5 hours. How many minutes is that? 0.5 hours. 30. Because 0.5 times 60 equals 30. So when you have decimal degrees and have to reverse it, you take the decimal chunk and first multiply it by 60 to turn this decimal into minutes. So 0.817 is 49 minutes. This number should be less than 60. That's how many minutes there is. Oh, but then 0.02 minutes, that means how many seconds you have. So now you take that 0.02 and multiply it by 60 again, and then you end up with the seconds. So you can do this with any add, subtract, multiply, divide calculator. I'm not even going to show you this button. It's called actually, it's pretty tough to find. There is a minute button on your graphing calculator. Can't use it in December. And there is a second button hiding in your calculator mysteriously. Then this other question, fine. There is a thing called a DMS button. I could type that decimal, find the DMS button, and then it does give me the answer. But I'd rather you know where it's coming from and not have to worry about where those buttons are. You make the call on that. Take a break for a second. I'm a little winded. I hope to whatever you believe in, this is not a problem. What do you know about those? I skipped one! What? Okay, now, supplement and complement. What did I say complement was? 90. What's supplement? Okay, but now what you need to do is, okay, I need to find the complement of this. Well, by golly, I got to find this as a decimal. What do I take 10 divided by? 60, because 10 minutes is 10/60ths of an hour. And then what do I have to do with 30? Divided by what? 3,600. Why? How many seconds are in an hour? 3,600. And then when I do this, and I did this in calculator ready form, press enter, you'll get 20.175. It's one button click on a good scientific calculator. A good, on average, $10 scientific calculator. Now what do I do? Well, to find the complement, these have to add up to 90, I'm sorry. So I take 90 minus that. I'll do the math. 90, 80, 70, oh boy. 90, 70, 69.825. Did I do that right? Is that right? Thanks. No one typed it? Okay. 180, 170, 60, 159.825. Now we're going to blow your mind. This is a multiple choice question. The multiple choice is in degrees, minutes, and seconds. Ay caramba. What do we first have to do with that decimal? What do we have to do with that decimal part? Not divide it. Multiply it by what? Multiply this by 60. Just that part. What do you get?
49,000
Whoa, 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 whoa. I don't think you use a decimal. 0.825 times 60. What'd you get? 49.5. So this equals, when I take these two and multiply them, 49.5. What does the 0.5 tell you? How many seconds are left over? No. 0.5 of a minute is 30 seconds. Or take 0.5 times 60 again. And then I think it's actually the same degrees, minutes, and seconds for the other answer as well. So again, to convert degrees, minutes, seconds to decimals, you divide by 60 for minutes, 3,600 for seconds. And then with a decimal degree, you multiply by 60 to get a minute back, and then you multiply that remaining decimal part to get seconds back. All right? Here we go. Now we got to move on to this. I hope I'm taping, recording. Okay, come on. What does this add up to become? You're going to have a whole bunch of questions like this. Maybe there's a little 90 crook in there, and they add up to 90. So basically, this is how you solve this. These two added together equal 180. All right, just a little real quick reminder. What do these become when you add them? 18x squared? No. And then what do you do to both sides? Divide by 18. If this is going to be a problem, ooh, this class might be rough. What's 180 divided by 18? So now what do you do with this when you look at the question up here? Find the measure. What do you do with this 10? Plug it in. 7 times 10 is what? 70. Kind of shortchanging the work because of time. 11 times 10 is 110. Lo and behold, what do these add up to become? When you plug the variable back in, then it satisfies the condition. And then I'm not solving the next one. Not gonna do it. But if it says they're complementary, what do these two add up to become? 90. Then you add these like terms. Oh, fine, I'll do it. Then what do I do next? If you're bad at solving equations, you better not skip a step. Skip a step. Did I still say it wrong? That one I didn't even mean to do. On your undo operations. And then what's 84 divided by 12? I was kidding. Sorry. Okay. Now, this better not blow your mind. This is the last one we're doing with degrees, minutes, and seconds. We got 7 minutes. This is grade school. Hey, just look at me. 4 hours. Isn't 4 hours the same as 3 hours and 60 minutes? So isn't 90 degrees the same as 89 degrees and 60 minutes? Yes. 1 degree equals 60 minutes. Why would I do that? Because To subtract these things, I had nothing to subtract from the minute part. So I needed to borrow a degree to the minute position and then subtract them. See, if I don't have enough here, I have to borrow from the degree part to get enough minutes to subtract from the minute position. This is one way. The other way, I'm just going to verbalize. Turn 51 degrees 28 minutes into a decimal. Take 90 minus decimal. Get that decimal answer. Convert the decimal back to degrees, minutes, and seconds. Did you hear all those steps? 5. This one's 1. This one's easier. What's 60 minus 28 is all you have to worry about. 32. What's 89 minus 51? Is it 38? Is that what you said? Mentally, my math brain is, it's already third hour and I'm starving. I'm about to faint. Okay, so the brain's kind of... Now watch how I do this one by hand. Again, if you don't like what I'm doing right now, you should, because it's actually easy. I'm sorry, it is. Turn these into decimal, decimal, decimal. Add, subtract the decimals. Get your decimal answer. Turn your decimal back into degrees in minutes. Blah. Now, what's PEMDAS mean? PEMDAS means please, or parentheses, exponents, multiply, divide. Does that mean I add first and then I subtract? No, add and subtract are what? Together. So I'm just saying that. What if this was switched? Do I add first and then subtract? No. We got lucky on that, so just be aware that that's the case. Because you know what I'm going to do? I'm going to do this the Mickey Mouse grade school way. I'm going to take 5530 and add it to 1244. And I'm not going to panic yet that the minutes section ends up being what? What do you think would be a problem for a final answer for this? It's more than 60. So what, if that was a final answer, I would have to take 60 out of that and convert that to a what? A degree, you meant. All right? So 55, I know I'm not even done yet. I have to subtract yet. 55, 65, 67, is that right? Now I'm going to take that and subtract that from 8, 15, both components. That's how this subtraction works. And I'm telling you, this is a lot easier than the first thing I said with the degrees turning it into a decimal and so on. And we get lucky. What's 74 minus 15? I think it's 59, which is smaller than what? 57, 58, 59? Is this 59? Oh, that's weird. 59, 59. Okay. Here's the new stuff. Standard position. Before you put your stuff away, you might want to put this down. Probably only 1/4 of you less actually did this last year. Here is the main idea of this stuff. All the other stuff is geometry review. You better tackle and fight through it. The only really new thing is a negative angle measure. Negative angle measure goes clockwise. Positive goes clockwise. Counterclockwise. I just reversed both of those because I'm nervous about the time. All right, but here's where an angle is going to be stuck. This is going to happen almost all year long, and you just got to get used to it. We're going to put angles on a coordinate plane. By the way, for a coordinate plane, you better understand that quadrant 1 is right here, and then there we go again. The normal way of direction is counterclockwise. Because in order, quadrant 1, the next one is quadrant 2 over here, then quadrant 3, then quadrant 4. We already did practice this a little bit. Quadrant 2, you're bigger than 90, but smaller than 180. And then your angle would land here. But before I consider that, your initial side for an angle measure stuck in a coordinate plane is always, always, always the positive x-axis. Initial means beginning. Terminal means end. So the terminal side could end up anywhere. What's a reasonable angle measure for this? Just throw out a guess and there should be almost everyone different. Go ahead. 50, 70. 15, hike. All right, 15 a little small. I'd say it's a little bit bigger than 45, right? What's a reasonable angle measure for the second one? 160, great. Sounds good. Okay, so on and so forth. All right, and then we talked about an angle that was greater than that. Now, this is going to be a term you may or you're just going to hear from me, but it's not really a big deal. Quadrantals are angles that land on a quadrant divider, like an axis. So obviously 90 lands on the positive y-axis. Okay, again, your job is to listen to the last 4 minutes. Oh, look at this next example. Co. What does the word co mean? The word co means same, right? Same, right? Terminal means end. So co-terminal, sorry, I'm scaring students as they're trying to get out, means same ending side. So let's look at this first example and really zoom in on it. So here we go. We have this angle measure. See ya. Let's start off with the basic. Okay, like I asked, what does this blue angle measure from here to here look like? Well, that looks like 60-ish degrees. That gets the whole shindig running here. Now, when I talked about illegal activities in Walmart's parking lot, I'm too cool. I'm going to go not 60. I'm going to go wee. Then stop here. And then the whole idea of us seeing, like, there's the Walmart sign that I showed you earlier. Both cars end up facing the Walmart sign perfectly. Someone not watching you do your motion, you'd look back at these two cars and not know the difference what those two things did. But one certainly did a lot more than the other one and had a lot more fun. Where's that 420 come from? You did a 360 and then an extra 60. That should not be rocket science. But now our new thing, and I had a chance, somehow I worked faster in second hour than this third hour, was what if someone decided, you know what, I don't even want to go your direction, I want to go this way. Whee! And then end up there. What's that angle measure? Well, first of all, it's this direction. The person second hour actually didn't say this. Negative. That's the big deal. Just the direction that you go dictates what's in front of the angle measure. This is a negative movement. And then what is this answer here? I want you to think about that online. All right, I want to hurry up. It's 300 degrees negative. And what's the relationship between these two? If you ignore the negative, these add up to 360. All right, that's really something that you need to hammer down and understand and make sure we get that pretty well. All right, so then you get it. So if I do a 110 in Walmart's parking lot, I could do the holy crow. Look at this one. Whee! Then 110. So this 830 actually represents, I hit red, 360, one rotation, 360, another rotation. This person's nuts. And then 110. But again, where they're looking, which I put question mark, what are they looking at after they're done? These two cars, even though this one was boring, they're both looking in the same position when they're done. This sucker just had a whole lot more fun doing it. So that's what you have to understand about co-terminal angles. They're multiples of 360 that are moved, added to whatever you started off with, blah, 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 blah. Really don't think this should be a big deal, but we're going to, keep hammering this home about how this works. Oh, what about this guy or girl? Boom, 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 there. What would that angle measure be? Well, it's based off of this one. And the answer is negative. Do you see that negative? Just want to make sure. 250, because I went clockwise. And I went clockwise negative 90, negative 180. Well, how did I get this last chunk? Well, I had to compare it to this. Because this angle and this angle incorporate 360 when you put them together, not thinking about the negatives, just thinking about what angular distance is covered by both angles. Okay? So, when I get questions that pertain to coterminal, this is all that we have here for those questions. And sorry, second hour, I said go to the end of the video. Somehow I did less third hour. My fault completely. So notice what it says. Find an angle of least positive measure, not equal to the given measure, same terminal, ending, same ending side. I think I cut off side. Oh, coterminal with each angle. I don't need to say side on that. Sorry. So third or second hour, we got to discuss this. 1,000 degrees is actually a ginormous angle measure. You don't have to graph it in order to do these questions, but I will. What's that angle measure? 360, Mr. Samuelus. What's this angle measure? 360 plus 360, Mr. Samuelus, which is 720. So what you simply have to do is subtract 360s out of this so that you could figure out what is the least positive measure that is coterminal to this. So when I subtract, since I don't have friends in here, I'm going to go ahead and do that here. One more. Lightning fast with the calculator. 280. Now, why do I stop there? Because 280 is less than 360. So the last movement of this, I'll get the arrows out of here and just flow right through them. 360, 720, and then another 280. Why do I know that 280 lands right here? It's because it's a little bit bigger than 270. So 280 is the answer. And I at least should know what quadrant it falls in just for practice later. So find the angle of least positive measure. Because if I subtracted 360 one more time, I'd get the negative angle measure, which would actually be this movement from here to here. And actually, just for fun, for giggles, what would that angle measure be? Correct if you said 80. Negative, I'm incorrect. It's negative 80. That would be negative 8, but that's not the question. The question says find the angle of least positive measure. So you get the idea. Give two positive and two negative angle measures. Two positive and two negative that are same terminal side, that are co-terminal to 90. Well, the first thing is maybe draw 90. There's 90 degrees. Whee! What's that angle measure? Add 360 to it. Whee! That's a lot more fun, isn't it? That's another 360 added to 450. That's 750, 810, I believe. And I'm not doing that noise anymore because I'm sure some of you are about to throw up here in that silliness that I'm doing right now. The next thing you have to understand is this. Okay, now find two negative angle measures. Well, what I'm asking for is an angle measure that I go this direction and I land in the same spot. Well, that's found by simply mathematically subtracting 360. That gives me negative 270. Or look at this. Negative 90, negative 180, negative 270. All three of these angles so far land here after starting from here. But again, I want you to constantly think of Walmart's parking lot, why these angle measures are different in how you get there. Some are more fun, some go in different directions. Then, of course, if I just subtract, 360 one more time, that's one full negative rotation, then the negative 270. So I subtract 360 from this again to get the fourth answer. 570, 630, I think. I hope I'm not making any mathematical errors. All right, I'm almost to where we were second hour. So just bear with me. Hey, maybe it's good to hear it again. Give an expression that generates all angles. And I think actually I was not completely done with this. So what's the idea of doing coterminals? Well, the idea to get a coterminal to negative 90, by the way, negative 90 starts at this side, the initial side, the positive x-axis, and goes this way. So this is the angle measure, that arc that I've shown, and that's how we're going to draw these, an arrow designating direction. So how do I get here in different ways? Well, we know we could go this way and do a full rotation and then that. What's the relationship? Subtract another 360. Careful, not add 360. The way I went there, that's a negative 360 and another negative 90. Or I could go this way. Now we know that answer is 270, but don't you agree that negative 90 plus 360 is 270? So on and so on and so forth. So an expression is something with a variable. And the way to get to negative 90 every single time is to keep adding or subtracting 360 to it. So 360 gets the variable n, where n is an integer. I would like you to write that for right now, and then later we'll come up with symbols that say that. And by the way, when we use n for expressions on these types of questions, it will always represent an integer. By the way, an integer is any positive or negative number, not a fraction or a decimal. So what this makes sure is if I plug in 1 times 360 is 360 plus negative 90 gives me the 270. When I plug in negative 1, I get negative 360 plus negative 90. That gives me that first angle I showed that was different. 360 negative plus another negative 90. So this is the expression with this little condition written at the end, where n is an integer. We're going to do this in chapter 4 and 5 when we answer certain questions. All right, I'll probably stop on this one, and then that one I'll just wait for class tomorrow. So that's not the homework. I think look at the calendar. Don't even look at this one. Sometimes these don't mesh. So the calendar only, and then I'll finish this one. And I think at the end you won't be able to do one of the questions. Sketch each angle in standard position. Draw an arrow representing the correct amount of rotation. Find a measure of two other angle measures, one positive, one negative. This is basically everything I've just done for every single question. So 75 degrees is approximately here. 75 degrees. Okay, starting at the positive x-axis. By the by, this is the x-axis, this is the y. Boy, that drives me nuts when someone in CAT doesn't know their axes. All right, so sketch an angle in standard position. Draw an arrow representing the correct amount of rotation. Here's the amount of rotation, just what I said in the last one. That's how we're going to denote angles. We're going to show the arrow in the direction you moved, and stop in the quadrant that you stop in. This one stops in 1. Remember, 2, 3, 4. Now, find a measure of two other angles, one positive and one negative that are coterminal. I just said a billion times previous. More fun in the parking lot. 35. A little rusty in my math this year. So what that is, as the parking lot example shows, I should circle this in green because I'm going to move in green. Whee! 360 plus another 75. You land in the same spot. You land at the same terminal side. Co-terminal. If you don't know that word when you come in tomorrow, I'm going to be angry. And then, what's that angle measure? Well, that's 75 actually minus 360 to simply put it. Remember what I said? 75 in this negative angle measure should, when you drop the negative, add up to 360. So that's why this is specifically the math for that. Oh boy, I'm going to embarrass myself. 270, 285, but negative. All right, and that's negative 90, 180, 270, and then apparently this is another little extra 15, to get that angle measure. So that satisfies those directions, okay? Oof.